So I'm going to pick up here and I'll go into a live demonstration showing the platform, showing the application concept for smart agriculture and how we can deploy the platform and the various components to address that particular solution set. So I'm going to go ahead and log into the platform. And here you see is kind of a dashboard overview of what more of a management person would see in the context of the system. It gives you a quick overview of your connections, what's connected, what's the health of the connection, what type of APIs are being used, and what systems have been connecting in. Due to the fact that the platform is a multi-tenant environment, I have the capability to change between different tenants and environments in the system. Here you can see very focused on the demonstration platforms for Amdocs. You can see everything from different e-health solutions, smart ag, et cetera, and the different APIs. Right now all of our devices are connected. We have good connection health, and we have a very uniform use of APIs in the system. For the demonstration today, what I'm going to take advantage of is using some of our tools from a management portal perspective. Here you can see the things, or what we call the thing viewer, to actually go in and look at what's going on within that particular solution and how that's working. Today, the solution for Smart Ag is as a collection of a gateway that's at the site, and then that information is then being published from sensors over LoRa and then backhauled through the gateway into the network upstream, whether that's backhauled on a wired network or a cellular network as need be. So the actual RAD SecFlow gateway is the key gateway part of the system. And here you see that it last reported in 34 seconds ago, and the type of information that's going to be presented in the platform is going to be very specific to this device. Okay, CPU usage, memory usage, the types of things you would see at a gateway level, and of course the different types of things you may want to do with the gateway. You might be able to take action on specific endpoints to allow things to work, deny things to move data. In this particular situation, you have LoRa sensors that are bound through this gateway to communicate data upstream into the solution set, as well as the ability to tunnel into that gateway and remotely work with that gateway to take action on the particular solution set. So we have that type of activity going on within the network, but also we have the sensors themselves. So we can go take a look at any one of these specific endpoint sensors and see that the specific data for those sensors, things like the frequency that they're communicating at, their signal level, signal to noise ratio, things of that nature are being recorded, as well as the actual live data that we're interested in, from the sensors, the humidity, the light, the moisture level, ambient temperature. Typical agribusiness type of solution set for these. You'll also see there's associated alarm state with each one of these. Are we in a good moisture level for this particular sensor area, or are we in some kind of drought or dry alarm, or are we in some type of flooded or moist alarm, depending on what the different states may be for those particular sensors. So we've got those types of things to deal with. And what I'm going to do is actually go into some of the dashboards that would be used by an agribusiness professional, in the context of the solution set. So we'll go in and take a look at what the agribusiness professional would use. Smart agriculture is basically the technology of applying key indicators and measurements, basic attributes and parameters to a specific field status or livestock status, or what you might be working, to address within your solution set. So in this particular area, you might be looking at an area of the field and whether it's in need of irrigation or not, because we're going to be focusing on from a standpoint of smart agriculture today, the context of irrigation and the ability to automate that and to gain better control over your agricultural solution. But many other solutions exist in the agribusiness domain that could be addressed by the Amdocs solution as well. it could be livestock management and monitoring. It could be more advanced crop management where you may have sensors that go down into the soil and look at nutrients and things of that nature. It might be, at the germination phase or within greenhouses where you're first getting the crop started, or, something as advanced as autonomous equipment operations where you're starting to monitor the equipment, not only the different attachments that are used in the equipment themselves, but, where they are, how they're scheduled, and things of that nature as we move more and more into precision agriculture. And here we, have other applications within agribusiness where you might be looking at, feed monitoring and management, where you even have solar cells in the middle of a field to power the gateway and the processor and the sensors to then be able to note and transfer, turn on pumps, open valves, etc., to make sure that feed and water are available, or that same technology applied within the actual barns and feed facilities themselves, where you'd be monitoring livestock into and out of that, as well as making sure feed's available at certain times of day, to balance what's needed in terms of the actual production, and up through, as I referenced before, precision farming, where we're getting more and more intelligent at the field level and the equipment level, where they're becoming more unified in their day-to-day operations. And then, of course, the application all the way up through autonomous equipment, where you might be working on a 24/7 type of basis. Here in South Florida, we actually have a lot of sugarcane production, and when it becomes harvest time, you're going around the clock to do that, and the ability to monitor the equipment, to monitor where the equipment is, the status of the equipment, to minimize any type of downtime against getting those fields, in for processing and delivery. So what we're going to be working on today is to take and expand, that story and kind of explain what's going on. For our solution scenario, what we're going to do is have some endpoint sensors. Those LoRa sensors that are referred to earlier have been configured to look at the ambient light, the humidity within the air, the moisture within the soil, and then the ambient temperature. So 4 key parameters that are very critical in agricultural type solutions. That information is coming in over LoRa into the RAD gateway to then receive that information, process it, and then communicate it, upstream or into the cloud platform, which could be done over, LTE infrastructure, 5G infrastructure, or wired, whatever the solution scenario needs to be for that particular, farm, implementation. And then the IoT platform would collect that information, persist it, but also make it available for dashboarding and logic in applications within the solution set itself. So what we're going to do is we're going to go through and we're going to process some live data, look at some of the screens that the agribusiness professional would use, and go a little bit deeper in how the solution could be deployed. So I'm going to just select live data here. And what this takes us into is kind of an overview display that would typically be, seen in the context of the agribusiness professional. It might be on his tablet, his smartphone, maybe a web browser, where he wants to be able to go, or they want to be able to go and look into an area of the field. Here we had 4 different sensors. That could be, 4 different areas of the farm. And then you can drill down and say, okay, for this specific field area, what's my, humidity level looking at, what's my moisture level in the field looking at, do we have adequate sunlight, how does this then affect, because obviously in a big data solution, all of this type of information could be taken and then correlated to other dynamics. How was their field production this year, from a standpoint of yield and things of that nature. Other information is also presented here. We have our device list where you can actually select directly into the different areas of the field or the different sensors that are associated to it. You also have, the capability to allow and deny the sensor activity, and that's more in the context of an area of the field maybe, either a crop rotation, or it may be, in cultivation or something of that nature, or you may be actually changing, irrigation equipment, and you want to ignore, false signals coming into the system. So you have the ability to effectively ignore the data and move those devices back and forth, and I can demonstrate that as well. In this particular scenario, you see the endpoint ID. You see that it's currently, in a connected status, but you also have the ability at your fingertips to move the different devices into or out of an active state. Now, to get the demo started, what I'm going to do is actually take one of these domains, and we're going to do something a little different than normal. We're actually going to go in and force it into a low moisture condition here. So we're going to go to a little lower level menu. Here is a menu showing much more of the sensory level information, signal to noise, signal strength, things of that operation or that nature. But what I'm going to do is actually, instead of turning the irrigation system on or off, I'm actually going to tell it that for this particular sensor domain, the 340 domain, we're going to go into a low moisture state. So what we've done is effectively, kind of force that condition into the system. If we go back over to our, to our actual thing viewer and take a look at the different alarms, you'll see that currently that area of the field is in a low or dry condition. And if we go back over to the actual agribusiness screen and take a look at that particular, area of the field, we'll see that indeed our moisture level has fallen to less than 20%. Our humidity level is low. You can see the drop here, as far as, our data going along at 30-some%, and then falling, drastically down to 28%, same being true for the moisture level. So now we're in a dry condition, and due to the fact that the system would normally in an automated deployment then cause irrigation to kick in, you'd crank up the irrigation pumps and start the irrigation process. What we're doing for the context of this demonstration is simply doing some alerting here to take advantage of alerting. So, what I should be seeing here as we go through the system is alerts coming in and being processed so that we know when we have, different temperature changes, alarm changes of that nature. So, we'll be, looking to see that as we move on through our demonstration. But right now we're in a low moisture state, and once we get, past the low moisture state here, then what we will do is, take action on it. Since we have a notification, we can, act on that. So what I'll do is go back to our control environment. We'll pick that sensor area again. And now what we'll do is actually take action to enable the, the irrigation. So when we do that, effectively what we're telling the system is, okay, now start up the irrigation pump, start the irrigation in that particular sensor area where it's been identified as being in a low moisture condition, and then, let that start running. And you see here, even at the lower level, you see some of the signals changing. The moisture in the air is going up because obviously the irrigation pumps have turned on, so there's water in the air, humidity and everything, going along that nature. So let me go back over and pick that. So if we go back and pick that area in the field, you can see that it's changed significantly. We have a very, high humidity level just due to the fact that the, water in the air from the irrigation sprinklers affecting the signal coming in. But in parallel to that, obviously the moisture in the soil is rising and going up as well, so that you're providing the actual irrigation that's needed, along the way to do that. So let me go check on our notifications here and see what we're getting. I'm just going to refresh that screen over there. One moment here. Let me see if I can pull in what is going on here. Let's see, we'll go in and sort on device-wise. Okay. So I've got some alert notifications here. Let's see, smart notifications set, low soil moisture. There's a low soil moisture notification. Right now we've got a high soil moisture notification as the as the actual, signal is coming in as well. So what we can do is then, it's basically saying, from the system automatically, you've got a high situation located in this particular area of your field. You may want to take action, if your pump is running. So basically, we know that we probably need to take action and stop the actual irrigation process so that we can get that back under control. So what we'll do is take advantage of, given the fact that we see the data, we'll go back out and in this scenario manually control the irrigation. Again, in a normal deployment, this would be done automatically, of course, but for the purpose of the demonstration, we'll control it ourselves. So what we effectively just did was send a command out to the actual irrigation pumps associated with that endpoint sensor, and we can see that we've already caused an adjustment in the moisture and the relative humidity, things coming back down and under control. If we go back out and take a look at the system, go look at that specific sensor area, we can see that things are back, under control. Our current moisture level is around 6% in the field. Our humidity level is back in the low 40s. Ambient temperature and luminosity, are there as well for the time of day that that we're showing. So that basically showed a basic overview of the operations, getting the live signals from the sensory level, controlling the moisture and such by way of actuating the irrigation pump system. What we can also do is show how devices could be taken, offline in the event that you want to ignore the data. So let's say that we wanted to take, this 342 sensor offline, the ability to move that, into an offline state is as simple as, again, a few finger clicks on your tablet, moving that over to the deny list, for the purpose of kind of moving things forward. I'll go ahead and force a refresh on the screen, but you can see that now that device is no longer selectable in the device list. It's been moved to the deny list so that it's no longer, available for operations. In a similar manner, we could actually go and default, a device if we wanted to, just to show a lower level recovery. So let's go ahead and do that. Let's take the 344 device and we can work with that particular device here. So what I'll do is put this device into a fault state, and the system lets us know that it's now obviously in the real world, this is the last thing you'd want to be happening. You'd want to be able to reply to a fault. So if you see a fault status, to be able to reply to that. And in our situation, what we've done here, at the actual, system level with live data is that we have gone through and we'll pick an actual one of these. We can see that right now this 344 is no longer connected, so we have an issue there. We see that this 342 unit is not being processed. So from a standpoint of operations, we have some issues here that we probably want to react to. If we were to go in and look at the 344, we would be, alerted that it's in a disconnected state. So data's, not coming in here. So that needs to be addressed. We can't even access the 342. But what we could do is to move that back to the 342, move that back to an online state so that it can be processed. So what we've done is made the request to move that out of the deny list back into the allow list so that it's acceptable on the device list. So if we go through and update the screen, we should see that the system has done that. It's moved the 342 system sensor back online. That data is available. Now we've still got this other sensor 344 in fault at this point in time. It's no longer connected, so we need to take action on that. Now to address that, in our solution scenario here, what I'm going to do is actually, reach out using the actual gateway and reach out to that endpoint sensor, where we have the different, the physical gateway here connected, to the sensors. And if we take a look at the actual, sensors that are available and take a look in the sensor list here, what we see is that 344 sensor is in fact in fault. And this is where the edge processing is being done. This is where the the data is being processed and whatnot. And so this is where the edge logic of the system, executes. So that from a standpoint of how that's put together within DeviceWise, you can see that, logic is applied at the edge so that as data comes in from the sensors, it can be processed in different ways in different states. And that's really a topic for a later conversation, but it basically gives you a little bit of context of the fact that the solution takes advantage of edge intelligence as well as platform intelligence. To get this particular sensor back online, I'm actually going to take advantage of the gateway here, and we'll change that state back to get it out of a fault state, and change that state here at the edge. And so what just happened at the edge is we communicated back downstream to that particular edge sensor, the 344 edge sensor, to basically perform a reset. And then as a result of that, so sensor performing the reset, then you'll see this just flashed yellow. If we refresh our screen, you'll see that now the sensor is back online. It's in an active state. It's cleared from a fault state. And similarly, if we go over and refresh our mail here as well, let's go ahead and pull that up, then you should see that we've had notifications come in for low and high moisture. I don't see the actual fault. I was going to actually refresh that. I want to make sure I'm on the right panel here though before I do that. So let's see if I can bring that up here, if it'll refresh when I do a search here or anything of that nature. Okay, high soil moisture, we see that. So we need to go see if we're getting an alert notification here today. So no, that got started. But the ability to see when we have notifications, the fault notifications and all cleared are part of the overall solution as well. So there, all of our sensors are online. Now this sensor, the 344, shows that it's once again connected. If we watch, as data changes, then we should see, live data coming into the sensor for this particular area of the fields and being processed as well. So it basically shows how the system can be managed at an edge level as well as at the platform level. So that if we move back out to an overview of all the different field areas, we see different things that the gateway reported in 26 seconds ago, that each of our sensors just reported in 13 seconds ago, but all of our states for the field are in a good operational state. So that's pretty much an overview of what I wanted to show today for the demonstration, the ability to actually to go through and show smart agriculture from a standpoint of the metrics and how the combination of the LoRa sensors with the RAD gateway and the Telit support for the DeviceWise at the edge and the Amdocs implementation of the portal can be used together to address smart agriculture to solve your particular problems. And obviously there are many other agribusiness type of solutions that this could be provided for as well. Hopefully it's been informational. It's been a pleasure demonstrating it. Thank you very much.